Welcome to the DIY Honda Garage channel. The DTC P2175 pertains to the throttle actuator control system, indicating that low airflow has been detected. The throttle actuator is a crucial component that regulates the amount of air entering the engine, which directly impacts performance and emissions. This error could result from various issues in the intake and airflow systems. In Honda HR-Vs from the 2016 to 2022 models, it's vital to address this error as it can lead to poor engine performance and increased emissions. Proper diagnosis and handling can prevent further damage to the engine and maintain its efficiency. When troubleshooting, it's important to have access to the Honda Diagnostic System, HDS, for accurate code reading and performance monitoring. DTC P2175 is triggered when the throttle actuator control system detects low airflow. This system comprises several components, including the throttle actuator, which is responsible for opening and closing the throttle valve, thus regulating air intake. The throttle actuator is typically located in the intake manifold area of the engine, making it integral to engine performance. Low airflow can lead to inefficient combustion and can provoke further diagnostic trouble codes if not addressed promptly. Failure to fix this can result in a compromised engine operation, affecting both power delivery and fuel efficiency. It's essential to understand these components to effectively navigate through the troubleshooting process. Several factors can cause DTC P2175, primarily focusing on the intake and airflow components. A blocked intake air duct may restrict the necessary airflow, resulting in inaccurate readings from the throttle actuator. This blockage could stem from a poor connection or physical debris obstructing the duct. But dirty air cleaner can similarly impede airflow, as dirt and debris can clog the filter element, requiring its replacement. Additionally, a faulty throttle body, whether due to malfunction or physical damage, could prevent the proper operation of the throttle actuator. Each of these components requires careful inspection during the diagnosis to ensure the vehicle's performance remains optimal. The symptoms associated with DTC P2175 can vary in severity, but commonly include reduced engine performance and poor throttle response. Drivers might experience hesitation during acceleration due to insufficient airflow entering the engine, which can make the vehicle feel sluggish. Furthermore, the check engine light will likely illuminate on the dashboard, prompting further investigation. These symptoms can significantly affect the overall driving experience, and if left unaddressed, may lead to more critical engine issues. Recognizing these signs early on can help avoid additional repair costs and enhance vehicle reliability. The first step in troubleshooting DTC P2175 begins with setting the vehicle to on mode without starting the engine. This allows the Honda Diagnostic System, HDS, to perform a comprehensive check of the powertrain control module for any pending or confirmed diagnostic trouble codes besides P2175. This preliminary check is essential, as other trouble codes can indicate a related issue that may also affect airflow or throttle control. If additional codes are found, it is advised to follow the diagnostic steps for those specific codes first. However, if no other codes related to this issue are present, the technician can proceed to the next steps, focusing solely on the air intake and throttle components. In this step, the technician must turn the vehicle to off mode, allowing for safer inspection of the vehicle components. The intake air duct should be carefully examined for any poor connections or blockages that could restrict airflow vital for the throttle actuator's function. This visual check involves looking for any disconnections or foreign objects that could affect air intake. If the inspection reveals problems, such as visible debris or compromised connections. Corrective actions like reconnecting, repairing, or replacing the intake air duct should be taken. Neglecting this step may leave underlying causes unaddressed, continuing the vehicle's performance issues. Following the inspection of the intake air duct, Step 3 involves a visual check of the air cleaner housing. This component is essential as it filters the air entering the engine and should have a secure connection without blockages. Any compromises in the air cleaner housing can lead to significant airflow issues. The technician must ensure that there are no gaps or misalignments that could allow for unfiltered air contamination, affecting engine performance. If any issues are found, the air cleaner housing should be replaced to ensure the system functions correctly. It's an often overlooked component, but central to maintaining clean air access to the engine. The fourth step focuses on the air cleaner element itself, which plays a vital role in maintaining optimal airflow to the throttle actuator. A dirty or clogged air cleaner can dramatically reduce the amount of air reaching the engine, leading to poor combustion and triggering DTC P2175. The technician must remove and visually inspect the element for any dirt or debris accumulation. If the air cleaner is found to be dirty, it should be replaced immediately, as this could rectify low airflow issues and restore engine performance. Regular inspection of this element can prevent recurring airflow issues and ensure the longevity of the engine's performance. In this step, the technician needs to manage the vehicle's engine temperature effectively by ensuring it cools down to a value of 77 degrees Fahrenheit, 25 degrees Celsius or less, based on the ECT, Engine Coolant Temperature Sensor 1 readings. Once the appropriate temperature is reached, the technician will utilize the Honda Diagnostic System, HDS, to clear the DTC from the memory. This action allows the onboard system to refresh and recognize any changes in the system's status after the preceding inspections and repairs. Upon clearing the DTC, the vehicle should be turned off again, and the engine is then started to monitor the DTC status, determining if the problem persists. This allows for an effective verification of previous repairs based on the conditions at the time of the original code being triggered. At this stage, the technician turns the vehicle on and selects the ETCS, Electronic Throttle Control System test, in the HDS to examine the throttle actuator control valve specifically. This test determines whether the throttle actuator is functioning normally. If the HDS indicates that there is an abnormal condition with the throttle actuator valve, it signals a faulty unit requiring replacement. A properly functioning throttle actuator is necessary for correct engine response and performance. Identifying faults at this point can save time and resources, preventing further diagnosed issues related to engine performance that can arise if this is not addressed. The seventh step involves a thorough visual inspection of the throttle body for any dirt, carbon buildup, or physical damage that could impede its operation. Starting by disconnecting the intake air duct allows for a clearer view of the throttle bore. If the technician identifies dirt or carbon deposits, cleaning the throttle body can restore airflow and prevent the recurrence of the P2175 code. However, if damage is evident, replacement of the throttle body will be necessary to ensure proper function. This step is crucial as the throttle body directly influences airflow, combined with customizations in the inlet manifold that affect engine operation. In this step, the technician focuses on the MAP, Manifold Absolute Pressure Sensor, which provides vital data to the engine control unit regarding the pressure within the intake manifold. By removing the MAP sensor, the technician can inspect its port for any clogging or restrictions caused by foreign materials or deposits. If a blockage is found, it's crucial to remove it promptly, restoring the MAP sensor's capability to function correctly. A compromised map sensor can lead to incorrect readings, ultimately triggering DTC P2175 as the engine struggles with airflow assessment. Ensuring the port is clear supports optimal engine performance and responsiveness. Step 9 requires measuring the atmospheric pressure and comparing it with the values read from the barometric pressure sensor. This check is vital as it indicates whether the baro sensor is functioning correctly by ensuring its readings are in line with the actual atmospheric pressure. If the readings are significantly off, further investigation is warranted into authorized service information related to the DTCs or symptoms present. A discrepancy may suggest that the baro sensor is faulty or that there is an issue in its circuitry. Correct evaluation of these parameters can ensure better diagnostics and lead to effective solutions, either through replacing the sensor or addressing underlying electrical issues. In this step, the technician must hold the engine speed at 3,000 RPM without load to accurately assess the performance of the MAF mass airflow sensor. This entails monitoring the sensor's readings while ensuring the values fall within the threshold of 4.9 to 6.9 grams per second, G in second. If the current readings do not match, it indicates that the MAF sensor/IAT intake air temperature sensor is malfunctioning and needs to be replaced. This component significantly influences the air-fuel mixture, and inaccuracies can lead to poor engine performance and further error codes. Regular monitoring of MAF sensor performance is essential for keeping the engine running efficiently. In the final troubleshooting step, the technician must check the IAT sensor, intake air temperature sensor, values after allowing the engine to cool to ambient temperature. The value from the sensor should be within a reasonable margin of the ambient temperature, specifically not differing by more than 5.4 degrees Fahrenheit, 3 degrees Celsius. Discrepancies exceeding this threshold indicate a faulty sensor, warranting its replacement. The IAT sensor plays a critical role in ensuring optimal air intake conditions for the engine's operation. Understanding this value is essential for effective engine management, and replacing malfunctioning sensors is crucial for restoring normal engine operation and preventing recurrence of DTC P2175. Once all troubleshooting steps have been carefully executed and necessary repairs performed, it is imperative to recheck the diagnostic codes using the Honda Diagnostic System, HDS. This step aims to confirm that DTC P2175 has been resolved and that no additional trouble codes are present. If the code remains, further investigation may be needed regarding the components tested or potential electrical issues within the system. Ensuring that all previous repairs and replacements were effectively completed is crucial for finalizing the diagnosis. This verification guarantees that the vehicle is operating efficiently and that the likelihood of recurrence is minimized. To help prevent the occurrence of DTC P2175, regular preventive maintenance is essential, focusing on key areas regarding airflow. Regular inspections of the air filter should be performed to ensure that it is clean and free of debris, as a blocked air filter can severely limit airflow to the engine. Cleaning the throttle body periodically can also contribute to maintaining optimal performance, as it reduces the buildup of carbon and dirt associated with air passage. Additionally, monitoring intake air ducts for secure connections and clear pathways will help minimize airflow issues. Engaging in consistent preventive maintenance can enhance engine performance and longevity, reducing the risk of encountering similar trouble codes in the future. In conclusion, DTC P2175 indicates a critical issue with the throttle actuator control system relating to low airflow detected. A detailed understanding of its implications is necessary for effective troubleshooting and repair, as airflow is vital for proper engine performance. Each troubleshooting step must be meticulously followed to ensure all potential causes are identified and addressed. Furthermore, adhering to preventive maintenance strategies can reduce the chances of this error recurring. Overall, maintaining a proactive approach can enhance vehicle reliability and performance, ensuring that your Honda HR-V operates efficiently and effectively. Please like and subscribe to the channel. See you next time.